Hey guys, how's it going? We are back at it once again with our topic on transformations, and today we're going to focus a little bit more on the topic of, more specifically, reflections as a transformation. So we kind of touched on it last time on the video. I believe it was 9.1 or 9.2. I can't remember what it was, but we are still on the section for chapter 4b. So we're going to talk a little bit more about reflections today, and you guys might notice that a lot of the same stuff that we've already talked about is in this section, but that's because we are going to apply it to something even further than that. All right, so we're going to expand on this concept. So in today's lesson, we're going to go ahead and identify the line of reflection, and we're also going to draw reflections in the coordinate plane. So let's go ahead and get started. So first off, we've already kind of talked about this briefly on the types of reflections that we might have. And we might have a line of reflection on the x-axis. This is one that we've already seen. And if we do have a line of reflection on the x-axis, remember, my x's will stay the same. The only thing that changes is my y's. So if originally it was a positive, let's say 3, now it's going to turn into a negative 3. You just turn it into the opposite symbol of that. So the description is that to reflect the point over the x-axis, you have to multiply its y-coordinate by -1, and you guys can see the diagram over here. Okay, so my p started at the top, right? X comma y was at the top, but after I reflect it over this line right here, it now goes to the bottom. Okay, so again, I like to give you guys small examples. So how about I give you this? If I gave you, I don't know, -5 comma 2. Notice that my x's will stay the same, so still a -5, but now my y is going to turn into a -2. This is the only thing that changed here. Okay, all right, now that was very specific type of line. It was a horizontal line that goes right through the x-axis. But what happens if we just have any horizontal line, not necessarily the x-axis? So go ahead and write this down. There is an distance between the vertices of the images and the line of reflection. I'll explain what that means a little bit more in a second. Okay, so let's take this little image here. All right, and I'm actually going to zoom into it. So let's say on this vertex right there, this is my line of reflection, right? So that's where I'm reflecting across. Well, if the distance between here and here is 2, then the distance between here and here also has to be 2. Okay, now it doesn't matter what the distance is, but what we know is that corresponding vertices have to have the same distance. So for example, about these two, if from here to here it's 8, then also from here to here it has to be 8. So that's all it means, guys. Those distances from any one of those vertices to this line right here of reflection have to be exactly the same. Okay, so just keep that in mind, because that's going to be a very similar type of response and type of definition for vertical lines. So let's go ahead and go on to the y-axis. All right, so if we have a line of reflection on the y-axis, notice my y's will stay the same because we're stepping on the y-axis, but my axis will now turn from a positive to a negative, or the other way around, from a negative to a positive. It doesn't matter. Okay, so they will be a little bit different. My y stay the same, but not my axis. So my description says to reflect the point over the y-axis, multiply its x-coordinate by -1. So once again, I'll give you guys a quick example. let's say you had -6, comma 3. Well, the only thing that's going to change is the x, so my 3 can stay, but now my -6 will now turn into a +6. Okay, so that's almost like the example here that you can see on the little graph here that we have, right? So we have a point P on the left top, all right, but it's reflecting over this line right here. So it's still going to stay on the top part of the x-axis, but it's now reflecting over the y-axis, so it's really just going, whoops, I went too far. It's kind of reflecting over to this side. So the only thing that's really going to change is my x's, not my y's. It's still the same height. It's just on the right-hand side now, so it's going to turn into a positive. Okay. All right. Now, same type of concept here, guys. For any vertical line, not just the y-axis lines, we're going to have a certain condition. So the condition for here, for any vertical line, is that is an equal distance between any of the vertices of the images and the line of reflection. Very similar description as to what we had for any horizontal line. So once again, let me zoom in here. All this really means is whatever distance it is from here to here, or actually let me go for my vertices. Whatever distance it is from here to here, let's say it's 1, then also the distance from here to here has to be 1. Distance from here to here, let's say it's 7, then the distance from here to here has to be 7. Okay? So just keep that in mind, guys. Those two distances have to be the exact same, regardless of where you are. Here, same thing. If this is 1, then this has to be 1, okay? From any vertice, from here to here. Actually, technically from anywhere on this whole diagram. So this space from here to here, my green, has to be the same as this yellow space, okay? So just keep that in mind as you are going through these problems. Now, we also had in the last video a reflection over the line y equals x. This tells me that my x's are now going to turn into my y's, and my y's are going to turn into my x's. So a good example here would be something like, let's see, -6, comma 3 will now be what? Well, they just switch roles. So now my y turns into my x, and my x will turn into my y. So I get 3, comma -6. They just kind of switch roles. So to reflect the point over the line y equals x, you have to interchange the x coordinate and the y coordinate. So just switch them out. And that's exactly what you'll have over here on this diagram. So once again, if you pretend that this is, let me see if I can do it small here. If you say this is -6, comma 3, then this one right here has to be 3, comma -6, which makes sense, right? This is the new one that we're adding to that, okay? Now we're talking about a reflection over the line y equals -x. So notice once again, my x still turns into my y, and my y still turns into my x. They're actually -y and -x, okay? So this is going to be the only difference, that negative right there. So once again, let me give you a good example, and I'll use my image. Oh, we actually don't have an image for that one. We'll go ahead and draw one in a second. Let's say, for example, I have 3, comma 4. Then my new order pair, Again, my x and y are going to switch, so this is going to be 4 and 3, but now both of them have to be negative. So this is going to be -4, -3. So let's go ahead and do a quick picture of that. Let's draw my two axes, my x and y axis. And if I have a point 1, 2, 3, 3, 4 right here, then if I reflect over the line y equals -x, which would actually, well, I'll show you that in a second, but then our new point is going over here. 4, 3. Our new point is going to be right there. -4, -3, because our line of symmetry now is actually going to be something like that. Whereas before we had a line of symmetry, y equals x going this way, now it's going the opposite way. As you guys can see, the distance between here and here looks to be the same as the distance from here and here. So now we're not only incorporating rules here, rules for how to switching the coordinates, but now we're going to talk about distance and how that has to be the same in order for it to be a true reflection. Okay? Alright guys, let's go ahead and look at a few of these examples here. Let me zoom in on this one. Alright? Well, let's read the directions first. It says, identify the line of reflection between the given images. So we have to find out which type of line of reflection do I have. Do I have the line y equals -x, y equals x, the y-axis, or the x-axis? Or I might have a new vertical line, maybe like, oh, I don't know, x equals 2, or a new horizontal line like y equals -3. We don't know. That's why we have to figure out right now. So what I'm actually going to go ahead and do is take my original image, my DEF, right triangle DEF, and I'm going to find the coordinates. Okay, so my coordinates here are 2, 4. For E, it's 5, 5. And then 4, 1 for F. Okay, the reason why I want to do that is because I want to compare those coordinates to my new coordinates of my image. So this is going to be -4, -2. For E, it's going to be -5, -5. And then for F, it's going to be -1, -4. So once again, guys, let's compare the first two. Remember, you have to look at corresponding letters here. So D with D prime. Let's take a look at those first. The coordinates for D are 2, 4, and the coordinates for D prime are -4, -2. Well, definitely not a reflection over the X. Definitely not a reflection over the Y-axis. Maybe the line Y equals X. Well, let's see. The line Y equals X tells us that Y turns into Y-X. Well, not quite. My 2 does turn into, or my X does turn into my Y, but it turns into a negative. So now I know for a fact. It's not the line Y equals X, it's the line negative X. Because that tells me that my X turns into my Y, and my Y turns into my X, but they turn into opposite values. And watch, I'll prove it to you. My original was 2, 4. My new one is -4, -2. You guys see that? Right? My X turned into my Y turned into my X, and now they're negative values. So this is correct. The line Y equals -X is where I am reflecting. Okay, so we are all done with example number 1. Let's take a look at example number 2. Alright, well, maybe you're thinking reflection over the x-axis, and you technically are wrong, but you're on the right track. So let's see. remember what we said about distances, guys. We said that the distances between any 2 points or any of the vertices in the corresponding triangles have to be the same distance. Well, first off, let's see what the distance is between these two r's. It looks like my distance here is 6, okay? And we know they have to be the same distance from my line of reflection. Well, if they have to be the same distance, then if I split 6 in half, what is that? That's 3. Let's see. Let's do that. 1, 2, 3. 1, 2, 3. Look at that. And actually, that's because right here, this is my line of reflection. Let's prove it to ourselves. What's the distance from here to here? 1, 2, 3, 4. So the distance from this C prime better be the same. So 1, 2, 3, 4. Still the same distance. Okay, so we have our line of reflection. What I need to know now is this is what? This is y equals -2. Okay, I'm right at -2 on my y-axis, and it's a line that crosses the y-axis, so my line of reflection is y equals -2. Okay, so this time it wasn't the x-axis. The x-axis is right here. It wasn't the x-axis because the distance from that axis to the top figure is much smaller than the distance from that axis to the bottom figure. Okay, so that was not it. What I want you guys to do right now is actually pause the video, and I want you guys to try out number 3 on your own. See if you guys can get number 3. All right, let's see if we can do number 3, guys. So first off, this definitely doesn't it doesn't look like a reflection downwards, right? It looks like a reflection to the side. And when we have reflections like that, they're usually a reflection along the y-axis, okay, or a vertical line. Now, obviously, my y-axis is right here, so it's not going to be a reflection across this line, okay? That wouldn't be right. But there is a vertical line here somewhere that is my line of reflection. Now, we've said in the past we need to compare distances. Let's compare my m's. My two m's are right here. One here and one here. What's the distance between them? 1, 2. Okay? So if I split 2 in half, what would it be? It would be 1 and 1. The distance between my x's would be 1, 2, 3, 4, 5, 6. Halfway would be 3. So 3 and 3. 1 and 1. Well, where is that? That's right there. Look at that. You guys see that? And between those two black dots, that's where I have my line of reflection. Okay? If you need to prove it to yourself again, do it with the z's. Look. 1, 2, 3. 1, 2, 3. Same distance, so this has to be my line of reflection. The challenge now is to find out what do we call that? Well, that's the line x equals 2. And once again, how do I know that? Well, let's see. Starting from the origin right here, I go to the right 2 on my x-axis, and this whole line, this vertical line, crosses the x-axis, so it has to start with x equals, and then we just found out that the value there is 2. So my answer here is x equals 2. So hopefully you guys got that as your final answer for that one. Let's see if we can figure out the rest of it. So for 4 through 6, we're being asked to draw and label each transformation. Okay. So the first one for number 4, it says triangle ABC needs to be reflected over the x equals -2 line. All right, well, where is x equals -2? It's right here. That's where it is. And I know for a fact that every single vertex in my new image has to be the same distance from that line of reflection. So from my point B, what's the distance from here to here? That's just 1. So all I really have to do is jump 1 to the other side, and I can put a point right there. This is going to be my B prime. Same thing with C. Jump 1, 2 to my line of reflection. So I have another 2 to the other side. That is my C prime. And then finally, from my A, I have to jump 1, 2, 3, 4. So I jump 1, 2, 3, 4 for my final point, which will be my A prime. Now I can connect them all. And look at that. If I get rid of all of this other stuff that I counted, I can see now that I have my proper reflection. All right. So that is the reflection over the line x equals -2. Notice they are the same distance from that line of reflection. Okay? Alright, so let's do the same thing for number 5. Actually, let's see. Yeah, let's do the same thing for number 5. Alright, so this says reflect over the line y equals 1. Where is the line y equals 1? That is right here. This is where 1 is on the y-axis. This is my line of reflection. So once again, I have to count from each of my vertices. I have to go ahead and count downwards. So this is 1, 2. So the distance from here to here is 2. So I have to count it once more. On the other side of my line of reflection. So this is my first point. This is E prime. Alright, same thing I'm going to do here with F. 1, 2, 3. So I go 1, 2, 3 on the other side. This is my F prime. Same with D. Looks like that was 5. So I have to go 1, 2, 3, 4, 5. And this is my D prime. Now I can erase all this other stuff. Let me go ahead and get rid of it. And I can connect my points. And let's see if that looks like a proper reflection. Look at that. Looks to be good enough, right? The distances between, like, for example, here and here look to be about the same. Distance from here to here look the same. So we should be all good. All right, cool. Excuse me. Now I'm going to do one last one here with you guys, and then I'm going to have you guys try out 7 through 9 all on your own because they are almost identical examples to what we just did. So let's go ahead and take a look at this one. So first off, we want to reflect over the line y equals -6. Now conceptually and visually, this looks a little bit tricky, right? We don't know exactly what that's going to look like just yet. So my recommendation to you is actually to go ahead and write coordinates for each one of these. So let's write those coordinates, guys. So for H, my coordinates are -2, -2. For G, my coordinates are -1, 4. And for F, my coordinates are -3, 5. Okay, now we know from this rule of reflection over the y equals -x, I have this specific rule. That is that any x comma y will now turn into -y comma -x. So not only do my x and y switch, but they also have to turn negative now. So let's go ahead and do my new image. So my h prime is going to be what? Well, this is actually going to be 2, 2. My g prime is going to be let's see, my 4 goes over here and it turns negative, so -4. My -1 goes over here and it turns into a +1 this time. All right, same thing is going to happen with my f. So this is going to be -5 and a +3. These are the 3 that I need to draw my new image. So let's go ahead and draw it. So 2, 2, that's my H prime. -4, 1, right there. That is my G prime. And then F prime is -5, 3, right there. So then, oh, whoops, my bad. I didn't do my G correct. It's -4, 1, not -4, -1. G prime right here. Okay, now I can go ahead and draw my connecting lines. And there we go. That is the image that it's going to create for my original pre-image. Okay, and once again, guys, I realize that doesn't look visually pleasing, but if you actually consider the fact that this is the line y equals -x, you're really reflecting along this line. This doesn't look all that great. Let me try it again. Let's try once more. There we go. That'll be better. We're actually reflecting along that line, and hopefully now you can definitely see the reflection. Again, distance from here to here looks about the same as from here to here. Distance from here to here looks about the same distance from here to here. We can start to see definitely reflection going on here. Okay. All right, guys, I want you guys to try out 7 through 8 on your own. We'll come back and we'll just briefly touch over those real quick. All right, and we'll just confirm that we have our answers correct. So go ahead and pause the video at this time and try those out. All right, guys, let's go ahead and take a look at these. So once again, this one is asking to do a reflection over the line y equals -x. I know that my rule is that x comma y has to be into -y x. So once again, just like earlier, guys, I asked you to go ahead and just write importance of all these. That'll help you out for when you're writing your reflection and your new image. So f is going to be -3, 1. T is going to be -1, -1, and D is going to be -3, -. Okay. So now, given my new rule, I have to do f prime. Whoops, t prime and prime. T prime and okay. So I have to switch my x and my y. So this is now a 1 and a 3, but this turns into -1. That turns into a +3. This just turns into 1, 1, and 3, 3. Those are actually pretty simple. So let's go ahead and graph these. Again, the only ones that I really need are this one, and that one. Let's graph those. So -1, 3 is right up here. That is my f prime. T is 1, 1. That's my t prime. And finally, D is right up here. So D prime. Now I can go ahead and connect all my dots. All right, there we go. And once again, guys, to give you a little bit better of a perspective, this is the line that you're reflecting over. And even though it's a little squiggly there, that is the line you're reflecting over. Now you can properly see that the distance here between any thing right here is pretty much same distance from here to here, okay? So definitely have a proper reflection. All right, FTD is being asked to reflect over the line x equals 1, so let's draw it. X equals 1 is right here. So that's my best attempt at my line of reflection. So again, every single thing has to have the same distance. So it's 2 and 2 here. That's my new point. 1, 2, 3, 4. So 1, 2, 3, 4. New point. And finally, 1, 2, 3, 4. 1, 2, 3, 4. Those are all my new points. Now I just have to go ahead and name them correctly. This is F prime. This is T prime. And this is D prime. Okay? And again, if I wanted to get rid of all this stuff, you don't have to. If it helps you guys, keep it on there. I just don't like to see all that clutter there. Now I can properly see that I have the right distances. So the distance from here to here, definitely like the distance from here to here. Okay? And then finally, one last one. We want to reflect over the line y equals 1. Well, y equals 1 right there. So the line of reflection is right here. Okay? So what happens? Okay, well, look at my f. The distance from f to that line is already on there, so my new f prime, is also going to be right on there. My point D is 1, 2, 3, 4. So 1, 2, 3, 4. D prime. And then finally T is 1, 2. So 1, 2. My T prime. So here is my new image. And there we go. That is a reflection, a proper reflection over the line y equals -1, or sorry, y equals +1. Okay, once again, this distance here is the same distance as here. Alright guys, I think that is enough for that. We're going to jump into our final thing for today. Actually, a few more final things for today. Let's go ahead and take a look at this. So it says, use triangle EFG with vertices EFG to create our new image, E prime, F prime, G prime, by reflecting over the y-axis. Okay, so this is kind of like a little bit of a review from last time. So I'm going to go ahead and graph my EFG, so -4, 3, -2, 0, and -1, 4. So E, F, G. Alright, that is my image right there. Right now I want to reflect over the y-axis, so this is going to be my line of reflection. And now once again, this is actually going to be simpler because now we know that they have to satisfy the same amount of distances. So the distance from here to here is 1. So my new point is going to be here. This distance has to be 1, 2. So 1, 2. My new point here of F prime. And finally, 1, 2, 3, 4. So 1, 2, 3, 4. And this is finally E prime. So there we go. Simple enough. Wasn't too hard. Whoa. Except for I deleted my points on accident. Alright, and here's my line of reflection. Sorry about that, but there we go. That's it. We just reflected over the line y, or I'm sorry, the y-axis, okay? Now this next one, we want to go ahead and use this rhombus QRST with vertices 2, 1. So let's graph it. 2, 1, 4, 3, 6, 1, and 4, -1. So this is my rhombus here. So it was Q, R, S, t. Okay, and I want to reflect over the line. Let's see, over the line y equals x. All right, cool. Well, we know our rule, right? We know the rule. The rule is that x comma y is equal to y comma x. So if I have all my original coordinates, so q was 2 comma 1, that is going to turn into 1 comma 2 for q prime. So q prime is 1 comma 2. All right, now for r is going to be 4 comma 3. So my r prime is going to be 3 comma 4. My s was 6 comma 1. So my new coordinate for s prime is 1 comma 6. And finally, for t, it was 4 comma negative 1. We switched them, so negative 1 comma 4. T prime, negative 1 comma 4. This is my new rhombus, right? So this right here was r prime, s prime, q prime, t prime. Oh, whoa, whoa, whoa. I totally did that wrong. I'm sorry. I was wondering why this didn't look right. Why don't I actually just use the coordinates? How about that? All right, so q was 1 comma 2, so q prime is right here. And then r prime is 3 comma 4, so that one was correct. This is the one that I think I messed up. This is t prime. And this is s prime. I just switched those two on accident. Sorry about that, guys. This probably would have helped if I had drawn my line of reflection, the line y equals x. I'll do my best job to get it right there, and now it makes sense. Again, you guys can probably draw better straight lines than I can, but that looks about right. That looks like what we should need. Again, this distance here is about the same distance as this here. Okay. All right. We're going to finish off this final activity by looking at these few transformations here. So it says identify the transformation between the following images. So we want to look at the transformation A to 1, sorry. So A to 1. Well, doesn't look like we reflected. So first off, you don't need to look at any of these right now. Don't even look at those. Okay? We just have to focus on these two. So let's see. Well, it doesn't look like we are reflecting. It looks more like we're translating. Okay? And now notice that all my values, all my vertices are going down. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. My x's seem to stay the same. So my rule here is going to be x comma y. My x's stay the same, but all my y's what? They went down 5. So it's x comma y, and turns into x and then y minus 5. Okay, let's keep going. Now we are looking at which ones? 1 and 2. So no need for this one, this one, this one, or this one. So just 1 and 2. Those definitely look like some sort of a reflection. So we have to find our line of reflection. Where is it? Well, let's see. The distance from here, 1, 2, 3, 4. From there to there was 4. So halfway would be right here. So this right here is my line of reflection. Okay? And what line is that? That's the line x equals 1. So this is going to be a reflection over x equals 1. Okay? So the first one, by the way, was a translation. All right, let's keep going. 2 to 3. 2 to 3 is actually another reflection, and I want you guys to take a shot at this one. So number 14, from 2 to 3. Go ahead and try solving this one on your own. You don't need to look at either of these right now. All right, so go ahead and give number 14 a shot. All right, guys. So hopefully you guys have figured out this one right here. Let's see if we can figure this out. So first off, distance from here to here from two corresponding points is 4. So halfway between there would be 2. So right here we have a line of reflection. Okay, that is my line of reflection. What line is that? Well, I'm on the y-axis at 1, 2, 3, 4, 5. So that is a reflection over the line y equals -5. Okay, let's erase all this once again. Let's go from 3 to 4. Oh, well, I have to, once again, let me eliminate all of this here for a second. We don't need that at all. I can go ahead and this definitely looks like a reflection again, so I have to count 1, 2, 3, 4, 7, 8, 9, 10, 11, 12, 13, 14. So 14, so 7 and 7. So let's see. 1, 2, 3, 4, 6, 7 is right here. This is midpoint. So really my line of reflection is going to be right here. And look at that, that's actually right on the x-axis. So my line of reflection here is going to be the x-axis. So reflection over the x-axis. And then finally, last one, let's go ahead and take a look at 3 and 5. So we get rid of any of these. So 3 and 5, once again, we can count the amount from one point to the other. Looks to be about 6, so 3 and 3. And midway between those was this right here. So that is my line of reflection right down the center. And that is actually my y. So reflection over the y. Okay, so the top one, number 12, was the only one that was a translation. That one just went straight down, so let me show you that one again. But every single one of these was basically what we did today. Those were all reflections, all right? So what was it again? Number 12, which was from A to 1. That's the only one that was a translation. It literally just shifted down. And it shifted down 1, 2, 3, 4, 5 on every single point. Okay, so that's why I wrote my rule. X to Y is now translating to X comma Y minus 5. Every single value went down 5. Alright guys, I realized this was kind of a long video, so why don't we go ahead and end it here. I think we went through everything that we needed to, and then we should be good to go now. Alright, so join me for the last video for section 4B when we take another quick look at rotation. Alright guys, well I will talk to you guys soon, and I'll see you later. Bye.